Now, with the ever-increasing concern about indoor air quality, many homeowners are upgrading to high-performance filters, and that is a good thing. But many of these upgrades are occurring without any thought, concern, or evaluation about that blower performance from their air conditioning or heating system. Now, for those of us from the field, we're all too familiar with no heating calls or no cool calls due to airflow restrictions. Filters that are either too restrictive or too dirty to allow airflow through the system. It's going to cause that indoor coil to freeze in the summertime, and in the wintertime, our furnace starts tripping on high temperature limits. So this video is going to take a look at a balance between airflow performance and filter performance as we start to get into these high MERV rated filters. So let's take a look at a furnace. We'll use the 60,000 BTU S8X furnace with a 3-ton drive. And we compare this furnace with a 3-ton outdoor unit, and we'll apply a 4TXCB004 coil, and we'll target 1200 CFM for cooling operation. So in looking at the blower performance tables, let's target that magical 0.5 external static that many out there like to recommend. And at that 0.5 external static, this blower is going to deliver 1168 CFM if we select tap 6. But before we can assume that 0.5 external static, let's take a look at the accessories that we're going to place in the airstream. Now, the coil that we put on top of the furnace is going to have a pressure drop. And this 004 coil, that is a B with coil, moving 1100 CFM, is going to have a pressure drop of 0.25 inches. Now, if I go to the furnace product data page, I'm going to notice a few things. One, it's going to tell me that the filter is not installed with the furnace. That is a field supplied accessory. The filter that fits the base of this unit is 16 by 25 inches, and they are recommending a high velocity filter. This is the type of filter that, when kept clean, it's going to keep the majority of the dirt out of the system, so my furnace and my indoor coil will remain relatively clean. But it's not the filter that's going to give me the best performance for that superior indoor air quality you may be looking for. Now, many system designers, when they're playing with duct design, they will assign 0.1 inches of pressure drop for an air filter. And oddly enough, this is pretty close to what ARI uses for their default setting as well. Now, if you read ACCA Manual D, they're also going to apply some pressure drop to my return grill, my supply registers, as well as the balancing dampers. And between all three components, I will have approximately additional 0.1 inches of pressure drop, which puts my total accessories at 0.45 inches of pressure drop, which only leaves me 0.05 inches for my duct design. And I can tell you without getting too far into this, that's not going to work. So 0.5 is out the window before I even consider a duct design, and let's pick another total static for the design, and let's bump it up to 0.7. So at a 0.7 design, I subtract my accessories, and now I have a 0.25 to work with my duct system, and that's going to be much more reasonable. So we designed the system at 0.7, we installed it, commissioned it at a 0.7 static, and we chose tap 7 from the blower performance table, and we're now delivering 1165 CFM for a system that's going to be reliable, as well as deliver the capacity we need for the homeowner. So time goes on and you go out there to do a maintenance call, and that homeowner's asking you about possible improvements to their indoor air quality, and they're looking at a better filter for their system. So the good news, if you're using one of our filters, we provide some filter performance tables. And if I'm just looking at installing another 16 by 25 1-inch pleated filter, which has a MERV 4 rating, and when you look at the pressure drop table, I see that at 1200 CFM my pressure drop is 0.13. That's pretty darn close to that 0.1 design I'm looking at, and I'm not going to be too concerned. As long as the homeowner changes the filter on a regular basis, I'll maintain that reliability and capacity from the system. Now, if the homeowner is not happy with a MERV 4 standing, and he says, I want at least a MERV 8, well, then you're probably looking at going to a 5-inch media. Because a 5-inch media with those deeper pleats, we can still deliver system reliability, system capacity, as well as improved indoor air quality. So when I look at the rating performance of this 5-inch filter, I see that the same 16 by 25, basically that 175 cabinet, at 1200 CFM, I have a pressure drop of 0.14. Almost identical to that 1-inch filter that only had half of the MERV rating. So how can I double the filter performance without really impacting pressure drop? And the answer is the amount of media that's within that 5-inch filter. Now my filter is 21 by 23.5, And when I take one of my filters and I cut away the outside frame, my media filter, when expanded, is actually 16 feet long. Folded up, it's only 21 inches. Expanded is 16 feet. So now I have a lot more area for that air to flow through. I have a lot more filter area for those particles to catch and stick and hold. And I still have good air filter performance with a MERV 8 rating. Now we also have the opportunity for the AccuClean or CleanEffects. AccuClean for American Standard, and on the train side, CleanEffects name. And we have a dedicated virtual session. So if you type in the AccuClean or CleanEffects based on your brand, you can see a dedicated section focusing on indoor air quality and how that filter performs for the homeowner. Let's take a look at the flip side of this equation, where the homeowner just goes down to their hardware store, looks at that good, better, and best, and buys a high-end filter. And the good news, when they look at the filter, it says it's good for 3 months. That'll save them some money. Now the chart that just populated here, this is going to show typical pressure drops with different MERV rated filters. This is not an absolute chart. You cannot apply this to all filters in general. Different filter manufacturers will use different technology, different materials, and different techniques in how they create, build, and manufacture their filters. So there will be different pressure drop ratings for the different manufacturers out there. And sometimes finding that information from these manufacturers can be challenging. So this chart, more for illustrative purposes only, but to get a better idea of what can happen to the system. Now when I look at this 16 by 25 air filter, moving 1200 CFM, I calculate about 430 feet per minute in velocity. So if I look at this chart, for general calculations, I can see that a MERV 4 filter will have a pressure drop of about 0.17 inches of water at a velocity of 430 feet per minute. But if the MERV 4 is not acceptable to the homeowner and they want better indoor quality, they may go to a MERV 6. And when they do that, the pressure drop on that filter, when new, increases to about 0.24. If they stick with a 1-inch MERV 8 filter, they're going to find the pressure drop goes to about 0.3 inches. And if they go for that best category, getting into the MERV 11, MERV 12 category, they're going to find the pressure drop on that filter climbs up to 0.4. Again, this is when the filter is clean. As the filter builds up dirt, that pressure drop is going to increase. And as that pressure drop increases, we have to ask ourselves, what chance does our blower have to move airflow across that furnace heat exchanger or air conditioning cooling coil? If the homeowner opts for a MERV 6 filter, we increase static pressure ever so slightly, and our total static for the system is about 0.8. If I select a MERV 8 filter, when that filter is new, my static is going to climb to about 0.9, and I need to move to torque tap number 8 to maintain the airflow that I need. Now if the homeowner purchases that best filter, my static pressure is now going to jump to over an inch. I'm off the blower performance tables. And whatever happened to my original ideal design of 0.5 for my entire duct system, when my filter by itself pretty much consumes all of that pressure drop. And again, this is with a clean filter. What happens in a month, 2 months, or 3 months down the road? But for some good news, you have the ability to evaluate system performance and inform the homeowner about the risks of applying the wrong filter to their system. And if the homeowner has purchased a filter, and you can break out your manometer and hook it up to the system to look at blower performance, and you pull the filter from the system, and you say, Mr. and Mrs. Homeowner, this is how the system was built, this is how it's breathing, and this is what I'm showing on the performance charts. Everything is looking pretty good. Now that standard high velocity filter is not going to impact this very much. But look what happens with the filter that you purchased. And you slide in that filter and you watch that static just climb and go outside of the blower performance charts. And you ask the homeowner, how do you think the system is performing? Well, it's impossible to tell. It doesn't land on the table. And this risk actually increases if I have that same 60,000 BTU furnace now with a 4-ton drive. And it's applied to a 4-ton outdoor unit where I'm now trying to move 1600 CFM through that same 16 by 25 filter. My velocity that used to be at 430 feet per minute just climbed to 575 feet per minute. So when I look at this table, I can see my pressure drop for all these filters increases. That MERV 8 filter by itself has a 0.4 pressure drop. And if I go to that best filter option, my pressure drop on the filter is 0.7 by itself. And again, this is a clean filter. So if indoor air quality is an important feature for your homeowner, and that's the reason they bought this filter, then look for ways you can expand the filter area. that the MERV rating on that filter performance shows, and you can maintain system reliability and capacity. And one of the best ways to do that is to expand or double the filter area. So when I look at this graph again, let's say I pick a velocity of 500 feet per minute, and I pick that high MERV rating filter, which has a pressure drop of 0.5. Now if I double the filter area, that means I drop the velocity by half. 50% of the air goes through one filter, and 50% of the air goes through the other filter, assuming I have my ductwork designed properly where both filters are breathing evenly. This means my velocity through each filter drops to 250 feet per minute. And as I slide down this chart, I notice my pressure drop went from 0.5 to 0.14. Or dropping the velocity by half will have approximately a 4-fold reduction in pressure drop. If that filter was whistling before, that noise concern should go away. The filter is likely to do a much better job of picking up the smaller particles. The velocity rate is much lower, so those little particles have a better chance to stick and adhere to the filter. And since I'm actually moving less air through the filter, I'm not going to have to change that filter as often. So you have the ability to review and make recommendations. You can look at the static pressure on the furnace or the air handler in comparison to the blower performance tables. And you can remove and reapply the filter that the homeowner wants for improved indoor air quality. And you can see how it's impacting their HVAC system. And make recommendations that can improve their lifestyle, improve the reliability, efficiency, and capacity of their heating and air system.